Hello everyone, my name is Mohammed Yeshu and I would like to thank you for the acceptance of our work applying advanced IoT network topologies to enhance intelligent city transportation cost based on a constrained and secured applicative IoT CoAP protocol. I will present this work following this plan. I will start with an introduction, then we will talk about the IoT Smart Transportation Platform. After that, we will see the proposed approaches. Next, we will discuss the results and finally the conclusion. So, for paper abstracts, we have combined between the transportation and Internet of Things. For the transportation, we talk that the satisfying of the demand of transportation with minimal losses is a major challenge today, and the reduction of greenhouse gas emission and promoting the deployment of renewable energy. For Internet of Things, we'll implement a synchronized and secured IoT smart transportation platform, and we will apply a network topologies, star, tree, mesh, and cluster, and we will see the terms of execution time and memory consumption. In this work, the objective is to choose the optimal path for the intelligent bus applying two approaches with different types of topologies and using the CoAP protocol with and without a security layer EAS SHA-256 and making a comparison between between the approaches, between the topologies, and between the implementation of the platform, secured and unsecured. Well, now we will talk about the IoT Smart Transportation Platform. For a better understanding, the figure illustrates the architecture of the platform. So, each station contains an IoT camera node, which takes photo, then the image will be sent to CoAP server, which is the intermediary that passes messages between the IoT camera nodes and the web server. Next, the obtained result will be sent to the web server, who will calculate the number of faces for each station and detect the optimal path that the intelligent bus can use. Moreover, to make this IoT object communicate, it is necessary to use a communication protocol. So, in our case, we used the CoAP protocol, and for data security, we added a security layer based on EES SHA-256. So, let's see what is this security layer. The security layer EES SHA-256 is a symmetric block cipher algorithm used for data security. It also employs a key with symmetrically shortest dimension. It uses a single common key shared by the sender and the reception to encrypt and decrypt a message. So, for the IoT network topologies, we implemented the platform applying different topologies. We have here the star topology. It's a topology which all nodes are connected to the coordinator. Then we have the tree topology. The tree topology is a topology with a tree structure in which all nodes are linked together like a branch, like here. And the mesh topology is a topology which every node can communicate with any other node, either directly or through the router. And finally, the cluster topology is a topology made up of collection of trees, like we see here. Well, for the approaches algorithm, as already mentioned before, our platform is used to give the mini electric bus to get the optimal path by taking a maximum number of people, avoiding the maximum stops. And to achieve this, we have worked on two approaches. The first approach After detection of the number of people in each station, the bus will move to the stations one by one and stops in each one except the station with 0% till to fill the capacity, which is 50. Then it will move to the nearer tram station, so we can get the optimal path. In the second approach, well, the idea of the algorithm is to move to 3 stations at minimum or to 5 stations at maximum. Well, I will resume this algorithm. It classifies the 5 biggest number, and it will make some calculations to choose 3 station, 4 station or 5 station, depending on the number of persons in each station. And here, to clarify how the web server treats the received images from the nodes and how it detects the number of persons in each station. It's like this. It gets the images here. It detects the number of persons and collects the data. And from this data, it detects the optimal path. We have here the examples of optimal paths results of the first approach. In the left result, as shown, the bus will move from the station to another. In station 9, it becomes full and it moves to the nearest station tram, which is station tram 2. The same treatment has been done for the second example on the right. So the bus gets its maximum at station 13 and moves to the station tram 3, the nearest station. Now with the examples of the optimal path results of the second approach. After collecting information about the number of persons in each station, we found that the optimal path is from the start point to station 2, 3, 7. Then the station tram. This is the example of 3 station, and that one is the 4th station, and this one is the 5 stations. In the second example, the optimal path is from start point to station 2, 4, 9 and 7. In the last one, the optimal path is from the start point to station 1, 4, 9, 10 and 11. Now with the results, we have here the execution time by topology and security. The red curve represents the implementation of the platform without a security layer. The gray one represents the implementation of the platform using EES SHA-256, and the blue one is just the average. The same treatment has been done for the memory consumption. So, according to the results obtained, we find that mesh topology takes more time to execute and consumes higher consumption memory compared to the rest of topology. And now with the average execution time and memory consumption by topology and security. As shown in the figure, the average execution time for mesh topology is higher than star, tree and cluster. However, for the average memory consumption, we notice that there is not much difference between the 4 topologies. So, as a result, for topologies, we can consider mesh topology as the best topology, even it consumes higher memory consumption and time. Why? Because it has more advantages than the others. Like if one of the routers faults, the nodes can continue the transmission of the payload to the server, because the nodes are connected to multiple routers at once. And for the results of the approaches, we have that to fill the capacity of the mini electric bus, the optimal path applying the second approach is shorter than the one in the first approach. which means that the time and the energy consumed in the second approach are less than the first, and that meets with our needs. Finally, I can say that in this work we have been able to create an intelligent and secure transportation IoT platform for guiding the mini electric bus to take the optimal path, using two approaches that had been tested in a real-time environment to find the suitable approach. And to make this work more efficient and secure, we have used the EES algorithm for encryption and decryption transmission payloads. For the future works, we will implement ECC encryption on our platform to compare EES with ECC and choose the best security layer for our platform. We will also create a third approach and implement it. And thank you for your attention.